More to get your head wrapped around what a three-dimensional figure looks like on a two-dimensional surface, okay? Because you're going to be seeing three-dimensional figures on your pieces of paper, which is two-dimensional. So it's more to get you thinking about, okay, if a plane cuts through this shape, what other shape could it make? So starting off here, we have isometric views or corner views. Are drawn on dot paper to represent three-dimensional figures on two-dimensional paper. So why do we do this, or why do people do this? Okay, so video game programmers use technology to make the gaming environments appear three-dimensional. As players move in the various video game worlds, objects are realistically shown from different perspectives. So for your video games, they are actually two-dimensional. They're just drawn three-dimensional using this kind of dot paper on the screen. Okay, so we can use this dot paper to draw three-dimensional figures. So the first one, we want to draw a cube with 4 units on each side. Okay, so to start off here, I need a line. So I have 1 unit, 2, 3, and 4. Okay, so that's 4 units there. Okay, I'm going to draw another line, 1, 2, 3, 4 units on that side. Now since this is a cube, right, the opposite sides have to be parallel to each other on each side. So that means I need a side over here that's parallel to the one I just drew. Okay, and same thing for that other side. Okay, now it doesn't look like much right now. But what I can do to finish drawing this cube, I can draw a line straight down here. Okay, and again, your opposite sides have to be parallel, so I need a parallel side to this one. And a parallel side to this side here. Okay, and I need a parallel side to this side. And this side here. Okay, so now this is drawn two-dimensionally, but you have to think of it as a cube. Okay, once you start thinking of it as a cube, you can see how it would become three-dimensional. Do y'all see the cube? Yeah? Alright, so in number 2 then it says, draw a cube with sides half the cube in number 1. I want you guys to draw that cube. Okay, it's similar to the one I just did, but it's half the side, like half the size of each side. Alright, so number 2, you should have drawn each side as 2 units instead of 4. Okay, so that would be half the size. And then it's basically the same thing. Since it is a cube, it's not asking you to draw a triangular prism or anything like that.
But can you?
It asks you to draw a cube.
I'm just asking.
You could draw a triangular prism. Questions on using your dot paper to draw those three-dimensional objects or seeing the three-dimensional object? Okay, next I want to talk about cross sections. Okay, so that is the intersection of a solid and a plane. Okay, so you're taking a plane, which we talked about at the very beginning of the year. Okay, a plane is a two-dimensional surface. It's flat. It's kind of like your piece of paper. Okay, so it's that flat plane, and this plane is going to intersect your solid or your three-dimensional figure. So it's going to cut right through it. So the shape of a cross-section depends upon the angle of the plane. Okay, so your plane can cut through something horizontally, vertically, at different angles. Okay, your plane doesn't just always have to be flat and horizontal. Examples of this. Okay, so there are several intersecting shapes that are cross sections of a cone. Okay, a cone is kind of, like an ice cream cone. Determine the shape resulting from each cross section of this cone. So if the plane is parallel to the base, okay, so that means it's going to be horizontal, parallel to the base, then the resulting cross section, here is my plane, right, parallel to that base of this cone, which is right here. Now the base of your cone is a circle. Okay, the base of a cone is a circle. So if I take that plane and cut through the cone at that same angle, that horizontal, it's going to make that base shape, which is a circle. Okay, so if I took plane, cut it through that cone parallel to the base, it creates this shape right here, which is a circle. So you see that plane still, and then that part of that cone right there. Does that make sense? Plane cutting through the cone. Okay, then another example with our cone here, B. If the plane cuts through the cone perpendicular to the base, okay, that symbol again means perpendicular. Write perpendicular out if you don't know what that symbol means. Okay, so perpendicular to the base and through the center of the cone. Okay, so perpendicular to the base is going to be vertical. So this plane is cutting the cone vertically. Okay, since my base shape again is this circle, and it's hitting here to here. Okay, that's where that plane cuts through. You can see the shape that it makes over here. Okay, so since that cone will go around, but I'm cutting it two-dimensionally downward, it's going to create that triangle. Okay, so we're going to have this triangle created. Okay, so we've gone through a horizontal, vertical, letter C. This one is going to be cut at an angle. Okay, so if the plane cuts across the entire cone, then the resulting cross section, if I have my plane here, okay, this one is at an angle. Okay, it's not horizontal. Horizontal was a circle, right? Okay, this one's angled now. So it's going to stretch that circle out. Okay, so my circle gets stretched out, which is actually called an ellipse. Okay, I know most of you want to say oval, but it's actually called an ellipse. Okay, which is technically an oval, I guess. Okay, so when I think about these cross sections, kind of think about a cake. Okay, so take that shape that you're cutting through, make it a cake. Okay, and sit it in front of you. Okay, and then you're slicing the cake with your knife. If I were to slice my cake sideways, what would it make? If I were to slice it this way and open it up, what shape would that make? Okay, that's what this cross section is actually doing. You're taking your three-dimensional figure and you're slicing it and then opening it up to see what shape is created. Okay, questions on those examples with a cone? All right, then this next section here, I want you guys to do this section. Okay, so read through it. You have your different cuts through that pyramid. And then the last question, you can use a computer or phone to figure that out. All right, so going through these ones here. So scientists are able to use computers to study cross-sections of ancient artifacts and structures. Determine the shape of each cross-section of the pyramid below. Okay, so this pyramid is a square pyramid. What that means is your base is a square. Okay, so in this pyramid, this bottom section here would be a square. Okay, so all four sides are the same. So if I cut this pyramid horizontally, okay, so across this way, since my base is a square, that means it's going to create a square when I cut it horizontally or if it's parallel to that base. So my cross section, that intersection, is a square. Now, the next one is an angled cross section. So your plane is cutting this at an angle. Well, in a pyramid, it gets smaller and smaller as it gets to the top, or that vertex, right? Okay, so that means this top section right here is going to be smaller than this bottom section down here. Okay, so if that top one is smaller, and then it goes down to the bottom section larger, what shape does that make? A trapezoid. Okay, so you have to think about the three-dimensional shape as well. Okay, it gets smaller and smaller as it gets closer to that vertex and larger as it gets closer to the base. Okay, the next one, this vertical cross section. So this is slicing it from the very top to the very base. Okay, it's really similar to our cone that we went through. So if you cut at the very top, okay, you have that one angle, right? And then all the way down, it's going to create a triangle. Okay, and here you see that it keeps going outward, outward. Okay, and then the base is flat there. So you have that triangle created with that vertical cut. Okay, where's the largest pyramid? In Mexico. It's not Egypt, it's in Mexico. Okay, so again, when you're given these three-dimensional shapes, think of it as something you're slicing, okay, with a knife or whatever. Okay, you're slicing something at that cross-section. Okay, last one. Ramona has a cake pan shaped like half of a sphere, as shown at the right. Describe the shape of the cross-sections of cakes baked in this pan if they are cut horizontally and vertically. Okay, so horizontal cross-section, okay, that one's going to be parallel to the base. So if it's cut parallel to the base, and this is a half sphere, your base is a circle. So if I cut it horizontally, what shape is that going to create? A circle. Okay, then I have a vertical cross section, so you're going to cut it straight down the middle. Okay, that cut would look something like this. Okay, right here. What shape would that make? If I cut it vertically, what shape is that? A half circle or a semicircle? Okay, half circle works as well. Okay, so you will kind of have to be able to draw some of these shapes three-dimensionally as well. So a rectangular prism, a triangular prism, a sphere, I'm trying to think, cones and pyramids. Okay, so you will have to be able to draw these. One way that I like to draw your three-dimensional shapes is to draw the bases first. Okay, so your bases is kind of how these shapes are labeled. So say I wanted to draw a rectangular prism, right? I would draw a rectangle as my base, okay? And I would draw the second rectangle as well as your base. And then you just connect each of those points. Okay, so if I said draw a rectangular prism, that's how I would want to draw it. Okay, if you want to draw a cone, you can draw its base first, so that circle but elongated, right? Okay, and then I would just draw the cone this way. So you will have to be able to draw these three-dimensional shapes. So again, how I draw those out, draw the base first, and then kind of connect all the other pieces. Does that make sense? Okay, so you do have to think about that three-dimensionally. Okay, any questions?